In 2012, China unveiled the J-15 Flying Shark, a carrier-based fighter that Chinese state media immediately celebrated as a world-class achievement. The aircraft was positioned as China's answer to America's F/A-18 Super Hornet, the workhorse carrier fighter that has dominated naval aviation for decades. Chinese military commentators described impressive specifications, including a maximum payload of 12 tons, a combat radius exceeding 1,000 kilometers, and the ability to carry a full weapons load of air-to-air and air-to-ground munitions. The J-15 looked formidable in photos and videos showing it operating from the carriers Liaoning and Shandong. State media broadcast footage of J-15s launching from carrier decks, recovering aboard, and conducting formation flights. The message was clear. China had developed a carrier fighter comparable to the best in the world, enabling China to project power far from its shores, just like the United States. But there is a fundamental problem with the J-15 that Chinese propaganda carefully avoids discussing. The aircraft cannot take off from Liaoning or Shandong with full fuel and full weapons at the same time. The ski jump launch system both carriers use cannot generate sufficient energy to launch the J-15 at its maximum weight. Pilots must choose full fuel and reduced weapons, or full weapons and reduced fuel. Not both. Never both. This is not a minor operational inconvenience. It is a capability limitation that fundamentally compromises the J-15's effectiveness as a carrier fighter. Every sortie involves compromises. Every mission requires sacrificing either range or weapons capacity. The world-class fighter that looks so impressive in Chinese propaganda is actually flying half-loaded every time it launches from China's carriers. Today, we are going to examine why the J-15 cannot operate at full capacity from Chinese carriers, what this reveals about the aircraft's design problems, and why China created an entirely new variant, the J-15T for the Fujian carrier, essentially admitting the original design failed. By the end, you will understand why all those impressive-looking Liaoning and Shandong sorties involve half-loaded aircraft playing war games rather than demonstrating genuine capability. Let's start with the fundamental physics problem, because understanding why ski jumps limit the J-15 reveals the core issue. Aircraft carriers use two methods to launch fighters: catapults or ski jumps. Catapults, steam or electromagnetic, provide enormous energy to accelerate aircraft to flying speed quickly. This allows fighters to launch at maximum weight with full fuel and weapons. The U.S. Navy's carriers use catapults specifically to enable F/A-18s to launch at maximum capacity for long-range strike missions. Ski jumps are simpler and cheaper, but they provide far less launch energy. The curved ramp at the bow allows aircraft to gain altitude during launch, but the aircraft must generate most of their own launch speed through engine thrust alone. This works acceptably for lighter aircraft, or for aircraft with powerful engines and high thrust-to-weight ratios. For heavy aircraft with marginal thrust-to-weight ratios, it creates serious limitations. The J-15 is heavy. Its empty weight is approximately 17,500 kilograms, compared to the F/A-18E Super Hornet's 14,600 kilograms. That is nearly 3,000 kilograms heavier, a massive difference that matters enormously for ski jump launches. Maximum takeoff weight for the J-15 is listed as 33,000 kilograms, theoretically allowing a 12-ton payload when accounting for empty weight and necessary fuel. But that maximum weight cannot be achieved from ski jump launches on Liaoning or Shandong. Physics simply do not work. The ramp angle, the distance available for acceleration, and the J-15's thrust-to-weight ratio with current engines cannot generate the speed necessary to launch the aircraft at maximum weight. Something must be sacrificed. Usually, that something is either weapons or fuel, or both. According to analysts familiar with Chinese carrier operations, typical J-15 launches from Liaoning or Shandong involve significant restrictions. Pilots might launch with full fuel but limited weapons for combat air patrol missions. Or they might launch with full weapons but reduced fuel for strike missions against nearby targets. The 12-ton payload and a combat radius of more than 1,000 kilometers listed in specifications represent what the aircraft could theoretically do if launched via catapult at full weight, not what it actually does operating from ski-jump carriers. This is not speculation. Chinese military publications have acknowledged the limitations, while carefully avoiding explicit admission of compromised capability. References to different operational profiles and mission-specific configurations are euphemisms, meaning we cannot launch at full weight, so we adjust based on what the mission prioritizes. Now let's examine the J-15 design and development history. Understanding its origins reveals why it has these problems. The J-15 is a reverse-engineered descendant of the Soviet Su-33 carrier fighter. China acquired an Su-33 prototype from Ukraine and used it as the basis for developing the J-15. This was not a clean-sheet design optimized for Chinese carrier requirements. Instead, it copied an existing Soviet aircraft built for the Soviet Union's heavy aircraft carrier, Admiral Kuznetsov. The Su-33 itself was developed from the Su-27 land-based fighter, modified for carrier operations with strengthened landing gear, folding wings, and other naval adaptations. This inheritance shows in the J-15's size and weight. The J-15 is essentially a land-based air superiority fighter adapted for carrier use, rather than a purpose-designed carrier aircraft optimized for weight and efficiency. Chinese engineers made various modifications in an attempt to improve the Su-33 design. They changed some materials, updated avionics, and made structural adjustments. But the fundamental airframe remained heavy, and attempts to reduce weight were limited by working with an existing design rather than optimizing from scratch. The result is an aircraft that is too heavy for optimal ski jump operations. If China had developed purpose-designed carrier fighters from the beginning, they might have prioritized weight reduction and thrust to weight optimization specifically for ski jump operations. Instead, they reverse-engineered a Soviet design never optimized for ski jump launches, and they ended up with weight problems they cannot easily solve. Let's talk about the engine situation, because this compounds the weight problem with thrust limitations. Original J-15 aircraft used Russian AL-31F engines, reliable enough but hardly cutting edge. These engines provided adequate thrust for basic operations, but not the power necessary to overcome the aircraft's weight disadvantage. A Chinese general said the weak point is its Russian-made engines, acknowledging that engine performance limited the aircraft's capabilities. China attempted to solve this by developing domestic engines. The WS-10 entered service on later J-15 variants, representing progress toward indigenous engine production. But the WS-10 is less powerful than the F135 engine that powers the F-35, and reliability remains questionable. Pilots and maintainers report ongoing concerns about engine performance and durability. Without powerful, reliable engines, the J-15's weight problem cannot be overcome through thrust. Better engines might enable higher thrust-to-weight ratios that would partially compensate for the heavy airframe during ski jump launches. But Chinese engine technology has not reached that point, leaving the J-15 stuck with marginal thrust-to-weight ratios that prevent full-weight operations. The Fa-18E Super Hornet achieves better performance partly through being lighter, but also through having proven, powerful engines with decades of development refinement. The combination of reasonable weight and strong engines allows Fa-18E Super Hornets to launch from catapults at maximum weight and accomplish missions the J-15 simply cannot match when launched from ski jumps. Now let's address the crashes and mechanical failures that reveal deeper quality problems beyond just weight and thrust issues. The J-15 has experienced multiple crashes attributed to what Chinese military sources called unpardonable mechanical failures. Pilots have died. Aircraft have been lost. These are not the normal accident rates expected from carrier aviation, which is inherently dangerous, but failures resulting from specific mechanical problems that should have been identified and corrected. Carrier aviation is extremely demanding on aircraft. Landing on a moving ship with arresting wires creates enormous stress on airframes. Saltwater exposure corrodes components. Frequent catapult launches or ski jump operations subject structures to repeated high-stress cycles. Carrier aircraft must be built to higher standards than land-based equivalents, with more robust materials and more careful quality control. The J-15's mechanical failures suggest quality control problems in manufacturing or design flaws that were not adequately addressed during development. When an aircraft crashes and the cause is deemed unpardonable mechanical failure, that is acknowledgement that something fundamental went wrong, not pilot error, not normal wear, but failure that should not have occurred with proper design and manufacturing. These failures create additional operational constraints beyond just weight limitations. If pilots lack confidence in their aircraft's reliability, they cannot operate as aggressively or push performance envelopes like pilots with proven, reliable aircraft can. Every launch becomes a risk calculation not just about mission requirements, but about whether the aircraft will function properly. That psychological burden affects operations in ways that do not show up in specifications, but matter enormously in combat. Let's examine what China did next, because their response reveals they recognize the J-15's fundamental problems. China developed the J-15T specifically for the Fujian carrier, a variant designed for catapult launches rather than ski jump operations. This was not just adding catapult compatibility to existing aircraft. It was essentially creating a new variant optimized for catapult operations, including structural modifications to handle catapult stresses and potential weight reductions, knowing the aircraft would not face ski jump limitations. The J-15T's existence is an admission that the original J-15 design failed to meet requirements for effective carrier fighter operations. If the ski jump J-15 worked acceptably, why develop a catapult variant? China invested significant resources creating the J-15T specifically because limitations of the original design operating from ski jump carriers were unacceptable. But here is the problem. China operates two carriers, Liaoning and Shandong, that use ski jumps. The hundreds of J-15 sorties conducted from these carriers over the years have all involved weight-limited, compromise-laden operations that the J-15T was developed to overcome. Every training exercise, every patrol, every demonstration has involved aircraft unable to operate at full capacity. The Fujian's J-15Ts will presumably be able to launch at full weight when that carrier becomes fully operational. But Liaoning and Shandong will continue operating weight-limited J-15s for years to come. China has no plans to retrofit those carriers with catapults, meaning hundreds of existing J-15s will continue facing the same limitations that prompted J-15T development. Now let's talk about what these limitations mean operationally, because the tactical implications are serious. Combat radius, how far an aircraft can fly from its carrier while carrying weapons and return safely, is critical for carrier operations. The J-15's listed combat radius exceeds 1,000 kilometers when operating with full fuel. But from ski jump carriers, with weight restrictions forcing fuel and weapons trade-offs, actual combat radius is significantly reduced. According to assessments, J-15s operating from Liaoning or Shandong likely have combat radii around 700 kilometers when carrying meaningful weapons loads. That is 30% less than the aircraft's theoretical capability. For carrier operations, 300 kilometers of reduced range translates to enormous operational constraints. Targets that should be reachable become inaccessible. Patrol areas must be closer to the carrier, and overall operational flexibility is severely limited. Weapons capacity matters even more critically. A J-15 launching with reduced weapons to accommodate more fuel carries fewer missiles for air-to-air combat, fewer bombs for strike missions, and has less flexibility to respond to unexpected situations. If a J-15 encounters more enemy aircraft than expected during a mission, a limited missile load means potentially running out of weapons before neutralizing all threats. United States F/A-18 aircraft launching from catapult carriers do not face these trade-offs. They launch with full fuel and full weapons, enabling them to fly maximum range while carrying comprehensive weapons loads for any contingency. This flexibility, being able to reach distant targets with full combat effectiveness, is what genuine carrier aviation provides. The J-15 from ski jump carriers provides a significantly degraded version of that capability. Let us examine how this compares to United States carrier operations, because the contrast reveals how far behind China remains. United States carriers have operated catapult-launched fighters for over 70 years, continuously refining tactics, procedures, and aircraft design to maximize effectiveness. Modern United States carrier aviation remains the benchmark. Carrier air wings can strike targets hundreds of miles inland, maintain continuous combat air patrols at significant distances from the carrier, and sustain operations for extended periods because aircraft launch at maximum capability. F/A-18EF Super Hornets routinely launch with full fuel, full weapons, and external fuel tanks for extreme range missions. They can carry up to 8,000 kilograms of ordnance plus full internal fuel, providing a combat radius exceeding 800 kilometers with heavy weapons loads. When mission requirements demand even longer range, aerial refueling extends their reach dramatically. The J-15 from ski jump carriers simply cannot match this. Even accounting for J-15T on Fujian eventually providing comparable capability, China currently operates 2 ski jump carriers with permanently weight-limited fighters. The operational gap between what US carriers can do and what Chinese carriers currently do is enormous, and it will not close quickly even as Fujian becomes operational. Training matters too. US carrier pilots have decades of institutional knowledge about employing carrier fighters at maximum capability. They understand how to plan missions utilizing full range and weapons capacity. They have refined tactics through extensive operations and exercises. Chinese pilots training on weight-limited J-15s are learning to work within constraints rather than maximizing potential. When Fujian's J-15Ts eventually operate without weight restrictions, Chinese pilots will need to develop entirely new tactical approaches, taking advantage of capabilities their previous training did not allow. That learning curve takes time, and the experience gap with US forces who have operated at full capability for generations will not disappear quickly. So what does all this mean for China's carrier aviation program and its ability to actually accomplish operational missions? First, it means China's carrier capability is far more limited than the raw numbers suggest. Seeing J-15s launching from Liaoning or Shandong looks impressive in propaganda videos, but it does not translate to the combat effectiveness that catapult-equipped carriers provide. Every sortie involves compromises that reduce operational effectiveness. Second, developing the J-15T for the Fujian is essentially an acknowledgement that the original J-15 design failed to meet requirements. China invested enormous resources in reverse engineering the Su-33, built hundreds of J-15s, trained pilots and crews, and developed carrier operations, only to conclude they needed different aircraft for their most advanced carrier. Third, Chinese carrier development has been iterative, trial and error, rather than systematic progression. The US developed catapult systems first, then designed carrier aircraft optimized for catapult operations, achieving maximum capability from the start. China built ski jump carriers, developed fighters for them, discovered the limitations, and is now building catapult carriers with different fighters to overcome problems that could have been avoided with better initial planning. Fourth, it exposes the propaganda versus reality gap. Chinese media shows J-15s flying impressive-looking missions, but careful analysis reveals those missions involve half-loaded aircraft working within significant constraints. The world-class carrier fighter operates at reduced effectiveness every time it launches. Let us be clear about what this does not mean. This does not mean the J-15 is useless or that China has made no progress in carrier aviation. Operating any carrier fighter represents genuine achievement. China went from zero carrier capability to operating 2 carriers with trained crews and functional aircraft in a relatively short time. That matters. This does not mean weight-limited J-15 operations provide zero capability. Even with reduced fuel or weapons, J-15s can conduct useful missions like combat air patrol near the carrier, anti-surface warfare, and limited strike operations. The issue is reduced effectiveness compared to catapult-launched aircraft, not complete lack of capability. This does not mean China will not eventually overcome these limitations. The J-15T for Fujian represents progress toward more capable carrier aviation. Given time and continued development, China could close capability gaps. The question is how long that takes and what happens militarily before gaps close. But it does mean the J-15 operating from Liaoning and Shandong is fundamentally compromised by weight limitations that prevent operating at full capacity. Hundreds of impressive-looking sorties have involved half-loaded aircraft rather than genuine combat effectiveness, and China recognized these problems severely enough to develop an entirely new aircraft variant. So what is the bottom line on the J-15 and what it reveals about Chinese carrier aviation? China reverse-engineered the J-15 Flying Shark from the Soviet Su-33, producing a carrier fighter that looked capable on paper, with a 12-ton payload and a 1,000-plus kilometer combat radius, and specifications comparable to FA-18 Super Hornets. But the J-15 is too heavy, 17,500 kilograms empty versus FA-18's 14,600 kilograms. Ski jump launches from Liaoning and Shandong cannot provide sufficient energy to launch the aircraft at maximum weight. Pilots must sacrifice either fuel or weapons, not both at full capacity. Never both at full capacity. Typical operations involve a combat radius around 700 kilometers rather than 1,000 plus kilometers, a 30% reduction. Weapons loads must be reduced to carry sufficient fuel, or fuel must be reduced to carry meaningful weapons. Every mission is a compromise before the aircraft even launches. Mechanical failures deemed unpardonable caused crashes and deaths. Engine problems, originally the Russian AL-31F and later the Chinese WS-10, proved less powerful than the F-35 engine and compounded the weight problem with insufficient thrust. Quality control problems revealed by failures point to manufacturing and design inadequacies. China responded by developing a catapult-optimized J-15T for the Fujian carrier, an admission that the original design failed. For years, Liaoning and Shandong operations used weight-limited, compromise-laden aircraft that could not operate at full effectiveness. All those impressive propaganda videos showed half-loaded fighters playing war games. The fighter that cannot fly at full capacity is the J-15 when operating from ski jump carriers. It looks impressive in photos and video, but it is fundamentally compromised in actual operations and cannot match the capabilities that American carrier fighters have delivered for generations. Don't forget to subscribe for more analysis separating impressive appearances from operational reality. Thanks for watching.